Okay, sorry, I keep getting interrupted. Here we go. Okay, so now that we have these written down, our next question says estimate the square root of 28 to the nearest integer. Okay, so 28, what we need to look at, if we thought about it on a number line, right, we know that 5 is the same thing as the square root of 25. That's just a different way to write 5. And I know that the 6 is the same thing as the square root of 36. So if I'm looking at 28, it's going to be somewhere in between the square root of 25 and 36, but I'm just trying to figure out which one it's closest to, and it's closest to 5. So that's my answer. Okay, so we're going to do the same thing down here. 38, if I'm looking on my list, which one is that closest to? 36, which is 6. The square negative root of 105 is closest to 100, which is 10. The square root of 54 is closest to 49, which is 7. And then down here it says, recall that you can write rational numbers as the ratio of two integers. Irrational numbers are numbers that cannot be written in the form A over B. Together, rational and irrational numbers form the set of real numbers. Okay, so look at your next page, and I've broken it down. Real numbers are comprised of rational and irrational. Okay, and rational numbers are integers, which are our positive and negative whole numbers. So 8, negative 10, 756, negative 41. Okay, anything that is a positive or negative whole number. That it is also made up of fractions. So 1 over 2, 3 over 7, 85 over 4, 1 and 7/8. Okay, anything that's a fraction. It could be a negative fraction. And then it's also made up of terminating and repeating decimals. So like 0.4, 0.3 repeating, 0.81452. It could be 1.7. It could be negative 3.82 repeating. Okay, if it's a decimal that is either terminating, which means ending, or repeating, then it is a rational number. So what is even left, right? What could irrational be? Well, irrational numbers are numbers that never end and never repeat. Okay, so never end and never repeat. So like 4.81347601 on. There's no repeating. It's never going to end. It's just this huge, long, never-ending decimal, kind of like pi. It could be something with a pattern, like 0.15253545, on and on and on and on. If it never repeats, then it would be irrational. Or something like 7.12122, okay, on and on and on. And what that means as far as square roots is if it is the square root of a number that's not a perfect square. Do we know what the square root of 7 is? No, I know that it's going to be close, right, to 3, in between 2 and 3, but I don't know what it is. Well, if you actually tried to work it out, it would be a number that never ended and never repeated. Okay, so like square root of 105. That's not a perfect square. The square root of 85, not a perfect square. So if it is a square root of a number that is not a perfect square, it's going to be irrational. So let's go back and look at this list at the bottom of the first page. Okay, the square root of 100, well, that's 10, so that's rational because 10 is an integer. 0.6 is a repeating decimal, so it's rational. Negative 0.81, that is a repeating decimal, so it's rational. The square root of 70, is that anywhere up here on my list? No, therefore it is irrational. 1 2/9, it's a fraction, so it's rational. Negative 2.6457, Rational. It is a terminating decimal. The square root of 5. Irrational. We do not know what that is. It's not a perfect square. What about the square root of 49? It's 7, so it's rational. 0.81, 811, 8111. Irrational. It is never going to end, and it is never going to repeat. And then the whole number 11, rational, because it's just an integer. It's a whole number.